Okay, so hello, everyone. So right now, I will start a video, where I look at some creation science and talk about how inaccurate it is. So this will be fun. So let's get started. Also, one thing that I want to add is that I do have a slight stutter, so please be patient. And so anyways, let's start this.
Rock layers show? Well, they show that the ocean water's flooded over the continents. How do
No,
I
they
know
don't.
that? Because there are marine fossils in rock layers covering the continents. That's right, marine fossils. Wouldn't you expect if they were marine that creatures lived in the ocean, they'd buried in the ocean? Well, why are they buried up on the continents?
Because the rocks are once under the ocean and now they're not. It's not that complicated. For example, the rocks in the Himalayas, a lot of them were once under the ocean, but then India slammed into Asia and thrusted all of them upwards. It's really not that complicated.
They had to get transported, lifted up by the floodwaters and dumped up on the continents.
No, they weren't.
And wouldn't you and I expect to find widespread, rapidly deposited rock layers because the flood was a global and it went all around the Earth? Yes. We find rock layers that can be traced all the way across continents and even between continents. Let me give you examples. The Tapeat sandstone at the bottom of the Grand Canyon.
Okay, so actually, wait, hold on.
It's the first layer of the flood. It sits on that erosion surface that marks.
No, it's not. There's never a flood. Tapeat sandstone is like a. Well, sorry, that's a solicitor called me. But anyways, let's see. Yeah, so the Tapeat sandstone is formed in like a shallow marine environment and is not at all a flood deposit. The reason why we know this is because of physics. Well, it's because of the actual structure of the sandstone itself, and yes, and physics. So let's see.
The beginning of the.
There's something called those. So Stokes Law for the settling rate of particles is is a it's a very good way to know this. And if you were to put in a numbers for a flood that covers the whole planet, and you were to do all the calculations out, you would not end up with sandstone. We know what flood deposits look like. Flood deposits look like roughly that. It's a conglomerate of a fanning upward sequence, or it looks like, or else like a little more like that. Flood deposits are almost always a conglomerate. It is the way that forms when you have a large outflow of water. It increases the size of the size of the particles. So the physics behind this is pretty well understood. I mean, there's whole mathematical laws for it. So the physics of this is well understood, and geologists have understood this particular physics for a long time. And sandstone is not formed in that. And shale is formed in a very low energy environment. It's basically mud turned to stone. So is limestone is also from a coral reef that's also formed in very low energy environments. You can see that in this. There's alternating. There's some layers. There's some small layers of shale, and then limestone, shale, and then more sandstone. So and then up here, and then so all these rocks are very different. And well, actually, no, I said that wrong. So all the rocks here are showing a rising and falling sea level, and some sand and some sand seas at times. There's a newer lava flow from the Pleistocene and Holocene. Um, so and shale is a low energy environment thing, and so is limestone, and that's just it's physics. It's Stokes Law. You cannot argue with Stokes Law.
First layer of the flood, it sits on that erosion surface that marks the beginning of the flood. There we can see it. That's the view from the south rim of the Grand Canyon. That little cliff at the bottom there, sitting on top of an erosion surface. Let's look at it a little bit more closely.
It's probably the Vishnu schist. You can see the. Actually, it might be the Vishnu schist, but it really doesn't matter.
We can study its characteristics. You know what? We can trace that sandstone in outcrop and in drill holes all the way across North America, across to Greenland.
Some of these units are similar ages, and I think some of them are correlated. However, though, not all of them. And once again, it's all meaningless because sandstone is not a flood deposit.
You can go to Chippewa Falls in Wisconsin, and you can see exactly the same sandstone with exactly the same features, sitting on exactly the same erosion surface, sitting on the same crystalline basement. You can see it on a road cut in Missouri as well, in between. The same sandstone can be traced right across North Africa, right over to southern Israel, at Timnah. You've got the same sandstone with the same fossils.
Once again, I don't see any flood deposits. I see evidence. I do see evidence of floods, but that's in the small slot canyons here. But I don't see any flood deposits, though. All I see is sandstone, which once again is not formed in a flood. So
Fossils, the same features.
it doesn't mean you can't have small flood deposits within sandstone. I did see a sandstone once in a field excursion that had some very small layers of flood deposits in it. But you could tell because you could see because the grain sizes suddenly increased from small to small and it became a little bit larger, and there was kind of a and you could see the finding upward sequences within that. So and sometimes you can have them within sandstone, but once again we know what flood deposits look like.
With the same erosion surface sitting on the same crystalline basement. Only a global flood would do that.
No. Let's see. On the rocks here there's a series of normal faults around here, and that's why the rocks here are like that.
Limestone in Grand Canyon. Well, by the way, geologists are pretty smart. Why do you think they call it the red wall limestone? Because it's a limestone that forms a red wall.
LOL, some faulty humor.
And it has unique features. You know, I was in Ireland nearly 3 years ago, and Killarney Castle is built on this rock here, and my eyes boggled. It's exactly the same limestone as in the Grand Canyon. The same features, the same fossils, exactly the same level. So you can trace it across to England in the Yorkshire Dales, and you can, by the way, it's the same limestone in the Appalachians as well, so you got it in between, and you find the same limestone in the Himalayas.
I don't think all these are the same age. But
that's right. There's marine fossils near the top of Mount Everest. It's made out of...
Yeah, because Mount Everest was once under the ocean. No, it's not. 60 million years ago, India slammed into Asia. Actually, or was it 40? Can't remember. It's either... well, actually, I think it was 40. but it really doesn't matter the exact age. But I do know that a lot of the rocks here were once under the ocean, and now they're not because of the Himalayan because of the Himalayan o- o- um orogeny, and that's what an orogeny will do. Will thrust mountains up.
Flood deposited fossil rocks. By the way, this is my last example. The chalk cliffs of England. Remember we looked under the microscope this type of lime.
The chalk is very small grain, so once again, it's the polar opposite. It's kind of like shale. It's a pretty low energy rock. We notice because of physics.
Limestone is made up of trillions of microscopic shellfish. What I didn't tell you last time is that you can trace that limestone across the Northern Ireland, but you can also trace it across Europe to Germany, the Netherlands, Germany, Poland, all the way down to Israel, Egypt, Turkey, Kazakhstan. By the way, at the bottom of that cliff, a shepherd boy picked up 5 smooth stones to slay a giant. There's the same chalk beds as on the English Channel coast. And we've got the same chalk in the Midwest of the United States, from Alabama across to Colorado, from Nebraska.
Some of these are similar ages, so
to Texas. The same chalk beds. By the way, the same chalk beds are found in southern Western Australia. That's a global scale fossil graveyard made of all these trillions of microscopic shellfish. Well, what do the scientists say about the formation of this limestone called chalk? They say the chalk beds formed over millions of years as lime grain by...
Let's see, what other fossils do we find? It's a weird question.
Lime grain, and tiny shell by tiny shell fell to the ocean floor. They say a fraction of an inch every 1,000 years. But that's on the ocean floor. Where do we find the chalk? Up on the continent. What other fossils?
That's because it was once in the ocean and now it's not. Thanks to the formation of mountains and the thickening of the Earth's crust through so it's not that complicated if you've taken a class in structural. So, but he hasn't, so.
Fossils are buried in the chalk beds. Well, if we go to the Niobrara chalk in Kansas, we find it's full of crinoids, perfectly formed crinoids that have to be catastrophically buried. Or this fish didn't get time to digest its...
Actually, this fish has a perfectly logical explanation, it probably was eating it and choked and died. The flesh rotted away, and all that remains are the bones. That type of stuff happens sometimes. And think about it this way: if there was a flood that was so huge it covered the whole planet and it carved mountains out and deposited massive amounts of rock, how come this fossil was preserved? Wouldn't it be like smashed to bits? Another problem of this whole flood thing is if I go back the map of the Grand Canyon, okay, the one major problem with this whole flood thing, and also like and Stokes Law is the fact and that if there is a massive flood, what makes the flood deposit sandstone and then shale, then limestone, then alternating layers of shale, then more limestone, and then more shale, then more sandstone, then more shale, then more sandstone, then more shale, and then more sandstone, and then more limestone. is it like a like how does the nature of the wave, how does it change, deposit, all these stuff, especially shale, which is mud, which is very clearly formed in a pretty low energy environment. So how does a global flood make shale? How does a global flood make sandstone that clearly is deposit that clearly is wind driven? Or how is it somehow have fossils still preserved in the same spot, and they were and how does it have roots of plants or anything else that's preserved? Like, explain that one. Oh, that's right. He can't.
Fish didn't get time to digest its food. You see the size of that fish? It's 12 foot long. Would you bury that a quarter of an inch every 1,000 years, a fraction of an inch every 1,000 years? The fish would have digested itself and swum away, wouldn't it?
Hmm.
Or in the same chalk bed, you've got pliosaur fossils and turtle fossils 10 and 12 feet long across. You've got dinosaur fossils and bird fossils in the same chalk beds. How would you gradual, grain by grain, a fraction of an inch every 1,000 years on the ocean floor over millions of years, bury together such large sea, land, and air-dwelling creatures on the continents, not on the ocean floor?
On the continent, because it wasn't on the continent. It was on the ocean floor at that time. Or I think a lot of it was a shallow sea. But
See my point? Only if the ocean waters rose and swept across the continents, catastrophically burying these land and sea and air-dwelling creatures all together in this global scale fossil graveyard. That's the chalk beds.
no, once again, if that happened, it would look like that. Or or that or that or anything else that's not anything what he's talking about. So he clearly is not a geologist and knows nothing about knows so so thank you for watching, and please subscribe.